Hey, what's going on, guys? KIM here. So the last video had quite a strange behavior with my program counter jump into quite weird locations in the KIM-1 ROM. But the reason was very simple. I just forgot to implement the function write into memory. It actually just returned 0 and didn't write anywhere. Hence, every time I had to write to stack when the function call occurred, it just didn't write anything, and then when it was time to return back from stack, it just was resulting in undefined behavior. So that was the reason. So I've fixed that. So now hopefully my read and write routines are working more or less just fine. Also, I've reorganized the memory slightly a little bit. But that's not the scope of this video. So I'm still encountering like too complicated. I'm encountering the complications that I don't know how this should work actually. So how KIM-1 ROM should actually work, because I don't have a real KIM-1 to kind of single step, and well, even if I had one, that probably wouldn't help really. Probably the only thing that could have helped me is if that was a breadboard KIM-1, and if I've used my Arduino to connect the pins to the processor pins, and just like Ben Eater did in his 6502 tutorial series, just to monitor when the processor is reading and when it's writing and what exactly. Maybe in that case that would be the case, but yeah, just don't have that option. So I'm going from slightly bit different. I'm considering slightly bit different approach here. So I've managed to, well, first of all, a good news is that I've managed to find this memory map for KIM-1, and it's quite interesting. So it tells which memory locations are responsible for what in particular, and also this makes even more sense. Well, actually, so the most essential is like the 0 page, then the stack, then the user program, and this is the 1K of KIM RAM. Then starting from here and up to here, so this sort of a thing is located in 6530's chip, in 6530-003 and 6530-002, if I'm not mistaken. And I didn't know that it doesn't only contain this I/O registers, but also each chip has 64 bytes of RAM, and also it has around 1K of ROM. Well, I might be horribly wrong, because again, like, I didn't read the specifications. All this just like from my correspondence, and yeah, I just can't say that that's the case for sure. But that was already enough to actually define my to redefine my my memory in the emulator. So that was quite enough at the moment. So if we have a look at the definitions of this exact memory addresses, so you see like starting, so the most essential are this one, so 1740, 1741, 1742, 1743. So what they do, 1740 is A register data, 41 A register data direction, B register is data, 42, 43 B register data direction. So the point is, I was quite surprised, but both the 7-segment LEDs and the keypad are on the KIM-1. According to my friend Dominic Bumbacket, they share the same pins, which for me, like for my brain, is quite a bit surprising. But yeah, why am I surprised? So that probably yeah, because otherwise there would be needed like tons of pins that just not available. So yeah, it kind of makes sense. But anyway, a part of the problem of switching these pins from listening to input and turning them to like just swapping the read-write functionality of those pins is one issue that I don't know how to deal with at the moment. But another interesting thing that I've realized, thankfully to this amazing resource, which is the KIM Uno source code, the sketch for Arduino for a KIM Uno project, the KIM-1 emulator that runs on Arduino, written by Oscar Vermeulen. So here he actually describes what in particular these kind of addresses do. So whenever we write to address 1740, we actually set the individual LED segments, which makes sense. So whatever like want to display 8, then that's the matter of this write 1740. Want to display letter H or letter E or digit F or whatever. So this is the matter of this 1740 address when we write to that address. Then, well, data directions, not interested in the moment. And this one, 1742, is which of the 6 segments to lit up, basically. So we have 1, 2, 3, 4, 5, 6. So when we're writing to the address of 1742, we kind of write the index of which of this kind of the 7 segment LEDs to lit up. So this one or this one, maybe this one or this one, whatever. Well, at least again, I'm not claiming anything. This is just my noob's attempt to learn how things work. Okay, so based on this information and a bit of my assumptions as well, what I'm trying to do next is the following. So here I've defined. Oh my God, no, not here. Here I've defined the display object, and depending on which oh my God, which segment we're supposed to be writing to, we can initiate a sort of a value there. So I would rather just demonstrate how this. Well, it's a draft of the I/O of the custom software implementation for of the I/O for my 6, 7 segment LEDs, right? So if I go to the console, so just update. Oh, it's already updated. So if I just reference the display, so what I now do by hands via console, this is assumed to be done from the KIM-1 ROM when it writes to the certain specific addresses, right? So let's say here I want to draw the letter of 8, right? So for instance, 1, and to pass the value to the function, I want to say hexadecimal 18, and we got this value of 8. And let's say here, so this is 1, 2, 3, 4. For instance, here, kind of like 4. I want to put, say, value, the letter H, for instance, like this. And here we go, I got the letter H. But here is another problem occurring here, and it's a bit of an issue of this, of the library that I'm using. So the problem with the library, it kind of more like relies on, on the ASCII characters as an input. Well, at least ASCII characters are used as a sort of an offset. While the real KIM ROM actually relies on this specific codes, which are known as the 7 segment codes. So just to give you an idea, so now, for instance, in the display 4, we have the letter of H, and the 7 segment code for the letter H should be 76. So I didn't yet test this, but if we go to SSD4, which is the 4's 7 segment LEDs, and there should be 7 segment codes, displayed, oh my God, by 0x38. And I just want to say to string and hexadecimal, and here we go. So here just so this 7 segment codes are indexed by this. So this 38 is the ASCII character, the value for ASCII character capital H minus hexadecimal 20, which is minus hexadecimal 30, I believe. Minus 0, or I don't remember. It's somewhere in the library code. But the idea is that I actually want to use this 76. So let's say I want to draw a character on the LCD on the 7 segment LEDs display. So in that case, let's say into the A register, I want to load the value of hexadecimal 76. and then it would display the letter H. So that's the idea. Well, now in order to make it work, I need to load the value of this 38, which is not how the original KIM-1 software operates. So the original KIM-1 software operates based on this 7-segment codes, and actually even the display itself is not going to be working because it's just it would be just interpreting the things wrong. So I need to work around to make some work to change the library a little bit, so it would be taking the inputs as the 7-segment codes instead of these kind of ASCII characters. And what else? And then I need to implement the routines intercepting the calls to 1740, 1741, 42, etc. But for now, at least 1740 to actually draw the character and 1742 to figure out which segment to draw the character to. So, I'll now try a bit of live code in here. So I don't know how it goes. Basically, it feels like there is a bit of stuff that I'm capable to do, hopefully. So let's go to here is the source code of the library, but it's from the wrong place. If I just I want to this here in the project with the one within the project. So here F9. So now I'm wondering. So I need what is known as display digit. So that's the function display digit. Where was I? Display digit is called here within the display. So far so good. Yes, so display digit here. Okay, and what it does, it takes the digit that we're sending to it, and then it looks up within the 7-segment code, and so actually I think that instead of this lookup, and we actually don't really need this entire switch case, because this library assumes that you might be having like 7-segment LEDs, 9-segment, 14, and even 16-segment LEDs, which is not the case. So what I need to do, I just need to set the segment code directly to the digit, right? And let's probably call it segment code, segment code, and let's call it like segment code. Okay, and if I did everything properly, if I now reload the stuff, then by entering the value of 76, I should be having this H here. So let's check this out. So go into display and like this. So go into display, and for instance, let's write the second one, and here 0x76. So if I did everything properly, it now should print the letter H right over in this segment. So let's have a look, and it does. And now it looks much better. So let's try to verify a few more characters. So for instance, 77 should print the letter A. So here, well, actually, let's start by starting from the first one. Let's try to print hello. Hopefully it works. So H is 76. So 76 H, then 2 should be well, a little E would be better, but let's use the big E. So 79, then 3 L goes for 38, and 38, and 5 we go for O, 5C, and maybe just 0 is gonna be better. So I'm not sure. Actually, I'm not sure what would be the the value for 0. It's a bit of a mystery to me, but yeah, probably 0 would be better. But anyway, at very least, these are the codes that KIM ROM actually operates on. And just why am I so sure about that, you might be wondering. Well, that's because if we go to the ROM, let's say to this convert digit, and here it is. Yeah, so what it does here, yeah, so actually to print the custom one, we should start from here. So turning off the segment, so it writes to SAD register that I've been mentioned in the beginning. Then yeah, enabling the output digits, so it's probably something related to read-write stuff, not sure yet. And here actually want to output the segments, which is essential. I don't know, maybe output digit enable, is this? Yeah, actually this is 1742. So most likely this this instruction actually tells in which which segment are we supposed to be writing the value, followed next. So it seems like the X register is holding the segment to write, and definitely A register is holding the value to write. So, but anyway, it actually looks a lookup table. So instead of using the lookup table on the library level as this was done before, it was done a completely different way. But anyway, so it was kind of relying on, I already broke that code, so 7 segment, well, it was somewhere here, it doesn't matter. So instead of doing that, it actually relies on the internal table, which is available in the KIM ROM, and it's somewhere, yeah, somewhere here within these tables. So it only, yeah, I guess it only goes for, well, I'm not sure what exactly it goes for. Probably only for digits and letters from A to F, just to output this. Like the hexadecimal values. But if user want to provide his own characters, so just like Bob Leedom did in his KIM Venture game, so this is still on the cards if you're just specifying your own custom table. So here you say like it's a custom table for characters, and the logic of conversion is more or less the same. So yeah, yeah, I think I'll probably stop at this point, because I'm not really sure what's going to be happening next. I will try to play around with intercepting this 1740 and 1742 calls, and try to write a yeah, it's not exactly writing a program. I will just forcibly initializing the A register to a certain value like this, and then I'll try to put the with the program counter to this convert digit here, and then try to single step the instructions just to make sure that it actually prints something not like manually by hands, but actually like from using the KIM ROM. So if I succeed with that, that probably is going to be the topic of the next video. So that would be something to showcase in the next video. And for this one, this is from my side, guys. So thanks for watching. Until the next time, and take care.